Good evening, everyone. We, the interns of IEEE Kerala Section, brings you the sixth episode of Color Your Space, Make Waves with Words. I'm Anjusha Wilson, and I'll be the MC for this session. For today's episode, we have Amit Tony Joseph with us. He is an IoT developer and will talk about an intro to IoT and its applications. Please put up your queries in the live YouTube chat. At the end of the session, the speaker will clear your queries. Now, over to you, Amit.
Thank you for the warm intro, Anjusha. So I'll just share my screen and share my video. Just a second. Okay. Okay, I believe I am both audible, visible, and my screen is also visible. Can I just cross-check it with the coordinators? Am I visible? Am I audible? Is my screen visible?
Yes, it is visible.
Okay. So a warm good evening to one and all present here. I am Amit Tony Joseph, and I am a third year electronics and communication engineering student from Government Model Engineering College, Kochi. And basically, like related to the topic, I am an IoT enthusiast. I've been working on IoT from my first year at college, and I have worked on several projects as well as I've done several hobby projects as well. So today's session will be a quick intro to IoT as well as the applications of IoT, the scope of IoT, the IoT, how to get started with IoT, and everything you need to know to get started with IoT. This will be a short, crisp session, after which you will know how to proceed in the field of IoT. So going into the slide straight away. Before getting into IoT, like I wanted to talk about maker culture. It's currently one of the most underrated buzzwords of the 21st century. Most of us would know like the famous makers or the DIY makers on YouTube, like Mark Rober, or even when it comes to the regional YouTube content makers, we all know M4 Tech. There are a lot of people on the YouTube out there who make stuff from scratch rather than buying them from the shop or rather than buying them ready made from the market. So like I am a maker because like I like making stuff, and that's where maker culture and IoT meets. So basically maker culture is about building stuff, or like if you're a fan of like those 5-minute DIY videos, you're a maker, or else you can have a general DIY attitude as well. Most of the times we know that like some of us buy Google Home Mini or Amazon Alexa, etc. to our home. But what if I tell you that we can literally make a Google Home Mini from scratch, your own custom Google Home Mini from scratch, under 30 minutes and under a cost of like 500 rupees. You need to give at least a minimum of like 5,000 rupees for such a device, whereas you can simply make one for yourself at a cost less than 500 rupees. So isn't that amazing? So that's what uh, intrigued my curiosity about this maker culture. So now going on to some random facts about IoT. So before going on to that, why I like told about maker culture is because IoT and maker culture are quite interlinked, because like most of the projects we do, or the most of the hobby projects that we do related to IoT, when you're doing it with IoT, you're actually like you're actually a maker yourself. You're actually being part of that maker culture itself. So now let's step on to like IoT. So this is some random facts that I was able to collect from the internet. I know numbers may be boring, but these are like quite intriguing. So like there will be 31 billion IoT connected devices by 2025. So like by 2025, we'll only have like 8 billion humans. So that will be like for at least 4 devices per human. So that is a big number, and that shows us that IoT is the future, and like there is a big IoT boom coming in. We all know about the industrial revolution, the fourth industrial revolution that's coming up, and IoT is a big part in it. And one of the other stat, every second, like another 127 devices are being connected to the internet. So these devices can be your smartphones, your laptops, your smart bands, like your home automation system. It can be anything. Any device that is connected to the internet comes under the hood of IoT. Also, talking with respect to the industry, 96% of all the businesses will use IoT by the end of 2025, because like in this era, what we have seen is automation, and IoT is clearly the mastercard definition of automation. And by 2025, all the industry, almost all of the 96% of the industries will be automated using IoTs. So as I said, like rather than calling it the future of IoT, the future is actually IoT. So why? So you may ask me why why IoT is the future. Mainly it's because IoT is a highly integratable technology. Like because it can be integrated with artificial intelligence. It can be integrated with machine learning. There are a lot of other advantages of IoT as well, which I'll be covering in the coming slides. Also, there are a lot of low power, high range IoT networks that are available as well. A lot of analytics that are being done on the IoT networks. There is a lot of scope for IoT, or a lot of integratability or adaptability for IoT, by which IoT has become the future. So this is a small, like what the reason for me being inspired by IoT, or why I got into IoT. So this is one of the reasons for it. Like most of us engineers would have seen this series called as Big Bang Theory. And in that like series, there is a particular clip in the season 1 wherein they show a small glimpse of IoT. Like I take this like chance to play that video, a short portion of the clip. If you want to like check out that video after this session, you may go onto YouTube and check out this for like better understanding. I just play the video for now.
Okay. The X10s are online.
Gentlemen, I am now about to send a signal from this laptop through our local ISP, racing down fiber optic cable at the speed of light to San Francisco, bouncing off a satellite in geosynchronous orbit to Lisbon, Portugal, where the data packets will be handed off to submerged transatlantic cables terminating in Halifax, Nova Scotia, and transferred across the continent via microwave relays back to our ISP and the X10 receiver attached to this lamp.
So actually what they did just now was they were actually controlling their lamp at the home using their computer. So they were actually discussing about the like the route in which the data packets traveled, by which the lamp got turned out. Like you may hear several, they're yelling out several words like San Francisco, America. So actually what happened was that by triggering that control from their laptop, the data actually traveled all across the world. So we know that the internet is a bunch of connected devices across the world, and there are like cables, that there are wires that are running deep into the oceans, by which through which all our data are sent and received. So when this character is actually like controlling this home lamp using the laptop, the data is traveling across the world. So that is the beauty of IoT. So you may ask why we are doing this when there is literally we can control it using a switch. We can physically like just click on it and turn on the light. So if you ask me why, like there is only one answer that I can give you: because we can. So that's the whole fun about IoT. I'll just continue the video.
Look at me! Look at me! I've got goosebumps. Are we ready on the stereo?
Go for stereo.
Hey guys!
Hello.
It's a little loud.
No problem. Turning it down. San Francisco, Lisbon, Halifax. Et voila.
Okay, thanks.
Hang on. Do you not realize what we just did?
Yeah, you turn your stereo down with your laptop.
No, we turned our stereo down by sending a signal around the world via the internet.
Oh. You know you can just get one of those universal remotes at Radio Shack. They're really cheap.
No. You don't get it. Howard, enable public access.
Public access enabled.
Boy, that's terrific, but I'll see ya.
No, hang on. See?
No.
Someone in Sichuan province, China, is using his computer to turn our lights on and off.
Well, that's handy. Here's a question. Why?
Because we can.
So that was much about the video. So you can like go to YouTube and search the video to like see more. So the question that the like Penny or the female character asked is quite relevant. So like why are you doing this? So I said before, because we can. So that's the so when there is actually a way of automating stuff, like for example, if you're lying on the bed and if you want to turn off your lights, like most of us would be lazy enough to get up off the bed and go switch off the lights. Instead, if you can take your phone in the hand, use Google Assistant and ask Google Assistant to turn off the lights, and when the light goes off, it's actually a lazy way, but still it's actually a cool way of doing it. And when it comes to the industry, automating such things gives us a lot of monetary advantage as well. So like as so Big Bang Theory is one of the famous series that most of the engineers should watch. Actually, it's a lot inspiring. So that was the inspiration or the motivation behind personally me and some of my friends getting into IoT. So that's about like a brief intro into IoT. So like the textbook definition of IoT might be boring, but still like IoT is actually the collection of all devices that have the ability to connect to the internet and share data. So this is something that I got from Wikipedia. But like if you ask me what is the much more cooler definition of IoT or the swag definition of IoT, I would say simple. Like I can define IoT in like 4 words: connect all the things. So if you'll ask me what are the things, I'll be coming to that. So IoT is basically the concept of connecting any device to the internet. As simple as that. It can be your smartphone, it can be your laptop, it can be your smart band, it can be your home automation system, it can be connecting. Like say you build an agriculture system and you connect it to the internet. So that's an IoT. So like IoT is basically a giant network of connected things. So I have been using this term things for quite a long. So you might be wondering what are these things. So these things can be like anything, like any device or any any device with an on off switch or that can be controlled can be defined as a thing. So it can be a bulb, it can be like as I said before, it can be like it can be some sensors, it can be some actuators, it can be temperature. We can take temperature readings or we can take humidity readings. All these things like when we actually connect it to the internet, they become smart and they are then referred to as things. So IoT is simply a giant network of connected things. And why we are connecting this? So that's the next question to be addressed. So by connecting these things in a particular network, we can collect the data, we can share the data, we can analyze the data, we can interpret them, and use it to understand the environment around them or use it to control the environment around them. So it's basically collecting, sharing, and controlling, to put it in a gist. So that is a simple definition of IoT. So if someone asks what is IoT, it is basically about connecting all the things together. Now, like going back to the basics. So like before IoT came, like IoT like came into existence at about like 2000s or by 2010, IoT like the IoT wave hit and it started to emerge as one of the emerging technologies. But before that, the the core of IoT or the father of IoT is just the embedded systems. So like embedded systems is one of the terms that is most scary for electronic students when they enter their first year. Like most of them think that embedded systems, VLSI, such terms are like quite something very scary and something very big. But actually, like when you actually dig deeper into them, it's just simple terms only. I'll just simplify it for you. So embedded systems is just any like any general purpose, any like system or any device or any microcontroller or any microprocessor that performs a specific function. So that's it. For example, I'll give you an example. So if you have say that you need to do some specific calculations for an exam, you'll never carry a laptop to do some calculations in your exam. You have a specific device, a small calculator that is specifically that is handy as well as compact, and that can perform several other scientific calculations as well. That is handy for your exams. So that is a specific application. Whereas our mobile phones, our laptops, etc., maybe more of a general purpose device, like when compared to the specific functions the other like small devices perform. So embedded system is generally a system that performs a specific task or specific application, etc. So the core of IoT is definitely embedded systems, and when we connect these embedded systems to internet, it basically becomes IoT. So that's about embedded systems and IoT. So, like just a like brief intro before going into IoT about embedded systems. So, like most of us will be familiar about Arduino as well as Arduino like boards. So, Arduino first came out in 2007. It was one of the research projects of one of the scholars in like Italy, in one of the colleges in Italy. So why it was brought up? Actually, this Arduino was the first step to the maker culture, or like before this, the introduction of Arduino, electronics was one of the fields where you required a lot of knowledge to start. Like if I'm interested in electronics and I wanted to do some project tomorrow, I just can't like step into it in such a way. I have a lot to learn, or I need a lot of prerequisite knowledge before getting into that. So in order to simplify that task, in 2007, a group of scientists, a group of research scholars came up with their research project. Like that was the Arduino, or it is basically a rapid prototyping board. So their whole intention was to like make any person or allow any person who is interested in electronics to make stuff or make or do projects or create stuff. It's basically simply putting it, it is for rapid prototyping. So even before that, like it required a lot of prerequisite, lot of pre-built knowledge to like do stuff in electronics. But after the introduction of this Arduino, it became a lot more much simpler. Because if today I have no, like say that I have no like if I'm a mechanical student or if I'm a chemical student and have no prerequisite knowledge in electronics, even then I can just like get an Arduino, do something with an Arduino, connect it to my laptop, just do some simple program. It even does not like the programming involved in Arduino can't be called as programming, because most of them are structured codes. Most of the templates are already, most of the templates and examples are already available on the internet. So it's actually a lot more simplified rather than in the olden period before 2007. So Arduino was one of the turning point in both embedded systems as well as the IoT era. So the Arduino that you can see in this picture is actually one of the first Arduinos. For all the electronics enthusiasts, you may think that this is the Arduino Uno, but it is not. It is the first Arduino that was introduced, and it is a lot different from what we see today. So these are some Arduino like development boards that are available today currently. Like most of the electronics enthusiasts or IoT developers would be familiar with these boards. Most of the times we use boards like Node MCU or like Arduino Pro Mini, etc., while we are doing the IoT application. So Node MCU, especially the Node MCU ESP8266 and Node MCU ESP32, is one of the benchmarks or one of the like trademarks of like the development boards that we use for IoT, because they are a lot more cheaper. They are a lot more compact when compared to the Arduino. It's similar to Arduino. It's just Arduino like boards only, but it's a lot more easier to use. It is a lot more compact, and it costs very less when compared to Arduino. So that's one of the main reasons for choosing Node MCU over Arduinos. So now, like let's step into some examples of IoT. So, like imagine that now it's almost rainy season and you're at your college, and when you reach home or when you reach your hostel, like you need a hot cup of coffee and you're lazy. So, what an IoT enthusiast would do is like from the college, when you're actually like getting out of the college, you can actually using your phone, like if you have a coffee machine at your hostel or your home, you can actually control it to, you can actually set it to make a coffee. Like you can actually give a command to make a coffee at like say 4:30, at 4:30 make a coffee, let the coffee be ready, so that you can directly go to your home, enjoy the cup of coffee in this rainy weather. Look, like, or else you will have to go to your like go to your home, turn on the gas stove, like a lot of steps are involved, and personally like I'm too lazy for that. So automating such tasks like is about IoT. So like most of some of, at least some in some of our homes will be, we might have implemented even smaller like segments of this IoT, like especially the smart home technologies. Like nowadays, most of the refrigerators or the air conditioners that come will be inbuilt with the IoT facilities, whereby we can control them with our mobile phones or laptops as well. Like we have seen like a lot of advertisement, especially that advertisement of this like Lloyd involving Mohanlal, the air conditioner. He's actually turning on his AC, like air conditioner, from a different place and chilling the place before he is entering the home. So such a lot of applications that are available, n number of applications that are available, about which I can go on talking day and day and day. So that's about the examples of IoT, like specifically smart home. So now I'll be talking about the magic of IoT. So like as I said before, the objects or things, like it's the same terminology. Things, how are these objects or devices converted into smart objects or the things that we refer to in IoT? So let's take an example. Say that I have a light bulb. So this light bulb can actually be controlled using a switch only. When you turn on the switch, the bulb turns on, and vice versa. But when you're actually connecting a microcontroller to it, say that you're connecting an Arduino to it, and you're controlling it from your phone. So when you have an app on your phone, and when you click the on button, the light turns on, and when you click the off button, the light turns off. So actually your phone is connected to the internet, your microprocessor, the Arduino is connected to the internet, and this Arduino is again connected to the light. So when I give this command to turn on the light, this like information goes to the microcontroller, the Arduino, via my Wi-Fi, and it sends an actuating signal to the light bulb to turn it on. So that is what is that's what's happening. So as a regular object or a regular device like a smart bulb is now converted into a smart object. So like that's one way of turning a device into a smart device. Another way would be like, for example, in the case of agriculture, there are several sensors available, like the humidity sensor, the soil moisture sensor. So whenever the moisture level in your soil drops below a particular level, you can set a trigger mechanism to automatically water the plants. So what we are actually doing is we are embedding some moisture sensors into the soil. We are checking if the water level is going below a particular threshold, and if it goes below, we are sending a trigger signal to the water pipe or something, by which automatic watering takes place. So instead of just like we going physically into the garden and watering the plants, we are actually automating this stuff. So normal devices or objects are now converted into smart objects or smart things. So that's about the whole concept of the magic of IoT, that is converting the normal objects into smart objects. So now going on to the architecture of IoT. So the architecture of IoT is quite complex. We know that most of us would have heard about the OSI model of like networking, the different layers that are involved in the OSI model, like the network layer, the physical layer, data link layer. So it's a lot complex, but I'll give you a simplified explanation for the IoT architecture. So basically, there are only like what you say, just a second. Okay. Basically, there are only simply four layers that are involved in IoT. The first layer being the devices. So as you can see, I've just annotated over here. Uh, there are there are several sensing devices as well as general devices that are available. so these sensors, as I said before, these sensors could be the temperature sensor, humidity sensor, etc., or these general devices could be your smart band, your smartphone, etc. So the first layer or the first level in your IoT architecture would be these devices, these sensing devices, as well as this or this general devices, or it can be actuators as well, these bulbs or anything that is connected at the towards the end. So that becomes part of this sensing layer. So it can be wired or wireless, or a lot of technologies are available as well. So then going on to the next layer, it will be I hope you can see the thing in the middle. So most of you would think it is like the routers that we have at our homes, the Wi-Fi routers, but this is actually a gateway. So it is similar to a router, but not exactly the same. So what a gateway does is, gateway actually collects the information from the sensors, and it's send it to the cloud for further processing. So basically, we have three to four layers. First, the sensors or general devices. The second layer would be this gateway, and the third layer would be this cloud. It is the cloud in which all the processing takes place, all the analytics takes place, all the management takes place. So the flow would be like, first, the information or the data is collected by the sensing devices, or sometimes the data is sent to the actuating devices. Then this data is being sent to the gateway. This data is sent to the gateway. So the gateway collects all the information, and it further sends this information to the cloud. So gateway is actually the middleman between the device as well as the cloud. So this gateway has also like a special feature by which not all the data are being sent to the cloud. I told that all the processing, as I said before, taking the example that I used before, if we have to measure the moisture content in a particular garden or a particular soil, the moisture sensor collects the data from the soil. So that comes under the sensing devices. The data is being sent to the gateway. So the gateway does a bit of processing. A small bit of processing is done at the gateway also, and further this data is sent into the cloud. And in the cloud, we can integrate several other technologies like AI, ML, like analytics, etc., and further actions can be triggered. The application level actions can be triggered from the cloud. And the application, as I said before, all the application level uh, all the application level things like the API calls, etc., are managed at the cloud level only. So that's about the general architecture of IoT. So basically, there are three levels only: the sensing devices or general devices, the second level being the gateways, and the third level being the cloud. So simply putting it, that's the IoT architecture for you. Also talking about IoT, most of us have a misconception that this IoT is all about connecting to the Wi-Fi, or most of us mistake internet for Wi-Fi. So internet is actually just a network of connected devices. There are a ton of technologies by which you can connect these devices. It can be Wi-Fi, it can be Bluetooth, it can be, like, you might have heard several other technologies like LoRa, Sigfox. LoRa stands for long range waves, and it is actually a low powered, high range technology by which you can actually transmit data over distance more than 10 kilometers at very low power. So the major disadvantage of Wi-Fi is that it consumes a lot of bandwidth. It is a very power efficient, and we cannot transmit data over long distance. So when LoRa comes into play, most of those problems are being solved, and it is one of the technologies that is coming up in these days, one of the core communication technologies. So LoRa is currently being used, but currently being replaced by Wi-Fi in some of the industrial applications as well. For example, in the case of in case of disaster or emergency rescue systems where Wi-Fi may not be available, or like if the like network connection like 3G or 4G may not be available, this LoRa can be a potential lifesaver. So a lot of emergency disaster rescue systems are now being built upon this LoRa technology as well. So as I said before, internet is not same as the Wi-Fi. Internet is just a network of connected devices, and there are a lot of other technologies that are involved in IoT, like LoRa, Bluetooth, LAN, or 3G, 4G, etc. Assets. So that's pretty much the IoT architecture. And as I said before, the all the like processing or all the application level things take place at the cloud level. And actually, the people who have like worked with web development would be familiar with the term APIs. So all the API calls are made from the this cloud server only. So based on the data from the sensing devices, or based on the information that is received, we can make API calls to trigger an action. So that's pretty much it about the IoT architecture. So let me just change the slides. So okay, so this is just the example that I told just now. Like we are embedding some moisture sensor or humidity sensor into the soil uh, in the garden at a backyard, and whenever the moisture level goes below a particular level, a notification will be sent to mobile applications that you have created. You can actually see a mobile interface towards your right. So a notification will be sent, and you can see the moisture. You can monitor the like the live data from anywhere across the world, as long as you are connected, as long as the mobile is connected to the internet, as well as the sensors are connected to the internet as well. So that is just the application of the architecture that I explained just now. So like you might see here, like you might actually see something that is indicated as MQTT or HTTP. So basically, you might ask how this data is being transferred from the sensor to the gateway, or this from the sensor to the mobile application. So most of us would have heard about HTTP, or like it is very familiar to us, Hypertext Transfer Protocol. So initially, like in the beginning stages of IoT, IoT also use this HTTP communication protocol. But one of the major issues of this protocol was that like it is for the web browsers and for the web-based applications, it is really helpful. But when it comes to IoT, like HTTP is like a bit heavy. It's also what you say. It's like it consumes a lot of power, as we have a lot of active devices that are involved, and it is also a request response based system. That is, we send a request and we receive a response from the person on the opposite side. So for IoT, there are a lot of disadvantages while we are using HTTP. So in like 2010, like 2007 or 10, new protocol was introduced, that is the MQTT protocol, like which we'll be seeing in the further slides. So now going on to the next slide. As I said, MQTT protocol, or the message queuing telemetry transport protocol. It is simply putting it, it is a lightweight communication protocol exclusively designed for IoT applications. It is very much secure. It only requires a low power when compared to the HTTP, and also it works on a publish and subscribe model. I told you that HTTP works on request response model, but this MQTT actually works on this publish and subscribe model, which we'll be understanding right away. So like as I told about the I explained an example before regarding the moisture sensor. So similarly, consider a temperature sensor. So we have a temperature sensor and like a temperature data that is being transmitted. Also, we have two devices, a computer as well as a mobile device. So in an MQTT protocol system, we mainly have two kinds of devices, or the two kinds of people involved. We have an MQTT broker as well as we have an MQTT client. So MQTT broker is actually the middleman between this our sensor as well as our clients. Clients are this computer and mobile device who use these data. So like in the HTTP, what actually happens is that we do not have this middleman. This MQTT broker won't be there. The communication would be directly between this computer and the temperature sensor, or the computer as well as mobile device. So even so, like what one of the drawbacks is that if a connection is not made, or if a request is sent and we do not get a response, or if the sensor is not connected to the internet, or the computer is not connected to the internet, we may not like the connection may not be successful, and there may be a lot of errors that can occur as we are using real a lifetime data monitoring. So so the main advantage of this MQTT protocol is that by introducing this MQTT broker or this MQTT middleman, actually, as I said before, it is a publish and subscribe model. What happens here is that we have several topics. So here the topic is temperature. Earlier I told about the moisture example. Similarly, consider that we are using a temperature sensor and we are monitoring the temperature in a room. And the topic is the temperature. And what happens is that the temperature sensor actually publishes the current temperature to the MQTT broker, aka the middleman, and the MQTT broker stores this information. So whoever requires this temperature data, whoever requires this published temperature data, can subscribe to this particular topic. So this computer, say that I need to access this data, access this particular data from my computer that is like listed here. I need to access this data from this computer. So what actually happens is that my computer is subscribed to the topic called temperature, and I can actually like get that data. So when I actually subscribe to that temperature, this MQTT broker publishes this data to my computer. So as I said before, it is a subscribe publish like based communication, whereby the clients subscribe to a particular topic that the MQTT broker has, and the MQTT broker in return publishes this data to the client. So that is what is happening. So one of the advantages is that there is no direct connection between the sensor and the client. There is an intermediary MQTT broker that is there, and hence even if connection goes off in between, the data will be stored within the MQTT broker. And as there is an MQTT broker, the data handling will be much more easier. Like you can have 10, 20 or thousands of topics, and you can actually subscribe to the topics that you require. So that's much about the MQTT protocol. So simply putting it, it's just about some of the terminologies that you need to know is like clients, like the computer mobile device, the sensors, as in the temperature sensor, the topic, as in this case, the temperature, and after that, publish and subscribe. So publishing is giving, subscribe is taking. So that's much it about the MQTT protocol that is used in IoT. So now going on to the next slide. Just a second. So like getting into hobby projects in IoT is one of the like best things that you can do to do before getting into core projects or doing serious projects, because there are a lot of like fun automating projects that you can do at a very cheap cost, like under 500 rupees, before actually like getting into serious IoT projects to get to know IoT better. So like as I showed you before, these are some general like boards, development boards like Arduino that we use in the case of IoT applications. Just a second. IoT applications. So as I said before, the ESP boards or the ESP32 or the ESP8266, such boards are very much common among IoT developers, because these are very much compact. These are very cheap as well. This costs around like only uh, 200 to 300 rupees when compared to the 1000 or the 900, 800 rupees of the Arduino. So, but the problem is that the processing capacity of this ESP boards, the small ESP boards, are limited to very small. They only have like 4 KB of RAM. So if you require like large processing capabilities, we might have to move into something like of sort of Raspberry Pi. At least some of you have heard about Raspberry Pi. It is almost a mini computer. We can call it a mini computer because it has a large processing capability, and it costs a lot as well. It costs about like 3,000 in between 3,000 to 5,000 as well. So in the case of like IoT applications involving a lot of processing, we can go on to Raspberry Pi as well. Generally, for hobby projects or for simple projects, we prefer ESP boards, like or they are also known as the Node MCU. Like so, these are some common sensor modules that you can use to get started with IoT. So so this one is actually an RFID sensor. So RFID, like most of your, so to give an example, like when you're traveling across the national highways, now all the like tolls are being automated by fast tags, right? So this is the same technology. We all have a fast tag on our car's windshield, and whenever we pass through that tolls, automatically the amount is being deducted from our bank account. So this is the same thing. So this is an RFID reader, specifically the RC522 reader that you can get under 200 rupees. Like a lot of, you can do a lot of projects with this, like library automation. A lot of cool projects can be done with this module. So going on to the next sensor module, it will be the second one. This is actually a temperature come humidity sensor. So it can be used to measure the humidity as well as temperature in a room. As I said before, like you can use this in a lot of IoT applications. So consider a project where like if the humidity goes below a particular level, if you have to like send a trigger to your mobile phone, you can do that with this sensor. So one of the advantages is that both the humidity, it has both the humidity as well as temperature sensor. It is also known as the DHT sensor. The third one is actually a temperature sensor alone. So in order to measure the temperature, like it is a dedicated temperature sensor using which you can measure temperature. And the fourth one will be this. The fourth one will be an IR sensor. So this sensor can be used to like detect what you say, like for fire detection or for getting analog values of light. So a lot of applications are also involved with this as well. Even you can make an like you might have seen the car, like automated cars or the like DIY projects wherein the cars just like the obstacle avoiding cars. All these can be built using this IR sensor as well. So the next one would be the most famous ultrasound sensor. So it is most commonly used to measure the distance, the same principle as in the sonar that is used in ships. We can actually measure distances up to 4 meter, like using this sensor. So actually, like in most of the, we know that most of the cars nowadays, we have this, when we are actually, there are reverse assistant mechanisms by which you hear a beep sound as you move closer to an obstacle while parking in reverse gear. So all those are based on this ultrasound only. So you can actually do a lot of projects related to IoT projects as well related to this using this ultrasound sensor as well. So the last one is actually core moisture sensor, and also like it is used to measure the moisture content in the soil. You can see the two pointed edges there. You can like insert into the soil and use it to like monitor the data lively. So like in the application that I told before regarding measuring the moisture content, so this would be the sensor that is to be used. Just a second. So that's much about the major sensor modules that with which you can get started into IoT. So like I'll share the slides. You can check out this later, and if you are interested, you can just buy this. All these sensors are very cheap. You can get them under like 200 rupees. Most of them are under 100 only. So you can get some of these sensors, get one ESP board and do this stuff all on your own. Nothing else is needed, just just some sensors or an LED, a development board like ESP or Node MCU, and you just need a computer. That's all you need to do an IoT project, and it's that simple. So that's pretty much it about the common sensor modules that we use. Like now going on to the simple home automation, you actually like the board that I have shown here. This board here is actually an ESP8266 board, and it is connected to one of the bulbs, light bulbs. Like I have connected to the AC power supply, and this is actually a relay module. You can't actually connect this ESP board to the AC directly. So I've connected it to a relay module, and I've connected that further to my fan as well as the bulb over there. So actually I can now control both my like bulb or my fan from a mobile application or a desktop application, or even using Google Assistant. So all these are platforms that are used to make these tasks easier. So actually this B icon you see here is of an application or a SaaS platform called Blink. So I'll show you a real demo like in the coming slides. So using Blink, you can actually you have a web-based application. You have a web-based application as well as a mobile application. So you can connect your this Blink application to your microprocessor, like in this case the ESP, and control the fan or the bulb. Also, you can in turn you can connect the Blink application to Google Assistant. Google Assistant using something known as IFTTT. If then that you can check it out later. So by that, if I like say, okay Google, turn on the lights will actually turn on. So when I'm actually taking my phone and triggering the Google Assistant using this command, an API call is being sent to the Blink server, and this Blink server connects to my Node MCU board, and in turn on the light or this fans. I'll actually show a real live demo over here after like some of the slides. So this is much about it. And also like most of the times when you're doing industry grade IoT projects, or like when you're actually doing it like when you're actually doing it in a bit of more serious way rather than a hobby project, make sure that you give a manual like trigger as well, because if internet, like if you're connecting to the Wi-Fi, if Wi-Fi is not available all the time, and you have like say that you have a water level system. Actually, I've implemented a water level system like in my home only. There is whenever the water level goes beyond a particular level, the motor will be turned on, and it will automatically fill in. So I don't need to like go to the motor, turn it on the time, and turn it off. A lot of water is being saved as well. So when you're actually doing that, if you're connected to the Wi-Fi and in between, like you lose your power supply, or you lose your Wi-Fi network, then the whole system will be under a severe threat. So you might want to add a manual trigger as well. So do not entirely 100% depend upon IoT unless you have a like 100% stable Wi-Fi as well as a stable power supply. So that's one of the warnings or precautions that you should consider taking. So, like before going to this, I'll try to show a small demo. It's nothing big, but I just set up a simple like I'll just turn on my video from my mobile screen, and I'll try to show it. Just a second. I hope it is visible. Just a second. Okay, so I hope you can see this. What I have done here is actually I have a light bulb over here. I have a light bulb over here. I have connected it to the AC power supply. I've connected it over there, and I've kept it here. And I'll just keep it aside for some time. So here I have the board I have been talking about all the time. This is an ESP8266 or Node MCU. I've connected I've placed it in a breadboard, and I've connected it to my laptop. I'm powering it using my laptop only, and I have programmed it in such a way that it can turn on and off the lights. So actually I've connected, as I said before, I've connected this light bulb to my AC supply. So I can't directly power this using my, I can't directly power this using my ESP board as well. So what I've done is like I've used a relay module. So this is actually a relay module, and what this does is like this helps us to like connect the microcontroller to the LED bulb when we are using AC supply. So I'll just demonstrate over here. I'll place the bulb closer. Okay. So I hope that you can see my screen as well. I am on the Blink dashboard. I'm presenting my screen. There I'm on my Blink dashboard. So whenever I'm this I've denoted this bulb as LED one. So whenever I'm turning this, actually I hope it's visible. So whenever I'm turning this LED button on, the light turns on, and whenever I turn it off, the light turned off. So that's pretty much how easy controlling your devices using uh, like Blink application is. So this is just a simple application. This takes just under 2 minutes to build this application. So here I've shown actually just a light bulb. So in your case, you can actually connect this to your fan, or you can connect it to whatever you want. The device can be anything. So in this case, for simplicity, I've just connected the bulb. So as I said before, maybe it can be your coffee making machine or anything. So that's pretty much it. Also, like if you can see my dashboard over here, actually, like there are also options that are available for taking data input. So if I'm actually, instead of my bulb, I'm actually connecting, like say I'm connecting one of the temperature sensors. Like I can actually get the data over here. I can display the data over here in this dashboard. So Blink is actually like you can have some of the features they offer it for free, but it also has a premium version. If you want to explore like a lot of options, you can like pay a small amount. It only costs about like less than 500 rupees for the subscription, and you can explore it on your own as well. So this is pretty much it about the application. Also, like similarly, like now I showed it using the web-based dashboard. So this is currently my laptop screen over here. Instead of this, I can control it from my mobile application as well. In my mobile application, the Blink app is available. In the Play Store, this Blink app is available. And using this Blink app, you can actually turn the LED on and off. I'm not showing it now because due to the time constraint, you can explore it on your own. The same thing is being same thing can be implemented over there too. To amp it up a level bit, so like I also wanted to show the voice recognition one as well. You can simply connect this Blink app to your Google Assistant. I've already connected it, but I'm not sure if I'll be able to show it or not. You can connect it there and just turn on your Google Assistant, say okay Google, please turn on the lights, and it will actually turn on my lights, turn on the lights at my home. So it actually works, but now I'm not sure if I can share my mobile screen and this both at the same time. So that also is quite possible, and it's very much working as well. So like now actually how this works is whenever I like turn on this LED bar, an API call is being sent. As you can see, this is that URL or that API. So even if I execute this, even if I take a web browser, uh, go to this go to this URL and click on that, my LED will, my bulb will turn on because it's just an API call. So that's just like I wanted to show you. I'll just show you just once again. Instead of like controlling it from my like what do you say Blink console, I can embed it in any website or my personal website, and I can even control it from there as well. So I'll just I've entered the URL and I'll click enter, so the bulb will turn on instantly. So the bulb just turned on as I like as I made an API call to that URL, and I'll just turn the value to 0 and I'll again click enter and it will turn off. So it's as simple as that. I can embed this into any website or anything, and I can turn on this light. I can turn on the light at my room from anywhere across the world, as long as my device as well as the bulb is connected to the internet. So that's much about the automation part. And now, just to conclude and wrap it up, why you should use IoT. So basically, as I said before, it's really fun and it's a like really cool or swaggy way of doing something. It helps in cost reduction. Like in the industry level, like when IoT automation comes, we know that in a lot of factories now IoT automations are being done. It reduces the cost by a lot. Also efficiency and productivity, also business opportunities, customer experience. So like say, instead of like turning on the lights turning on the lights physically using your hand, you can actually like turn it on using your mobile phones, right? So that's actually a more cool, or like what do you say, more fancy way of turning on the light. Also mobility and agility. So these sensors are very small, these are very compact, hence they are very rigid as well. So that's the reasons for why you should choose IoT. So everything has pros and cons, and even IoT has. So the main challenge that we face in the case of IoT is security and privacy issues only, because we know that we are humans and we are the ones who are controlling this IoT related system. So due to our mistakes or due to our like lack of knowledge, we can actually get into a lot of danger. And we can like all the device, we know that all our mobile phones as well as laptops may not be safe if you are connecting it to the, say we are connecting to the dark web or something. So similar problem exists here too. So like I could have shown a live demo of why this IoT is not preferred due to this security or privacy issues. The best way to show that would be using a search engine known as Shodan. You might Shodan is actually a search engine for what do you say, IoT systems. Any like system, any device connected to the uh, like internet can be searched on this Shodan. It's actually Google for IP addresses. You can call it that way also. Any device that is connected to the internet can be searched using Shodan. It's simply like I'll show Shodan to you. Okay, this is Shodan. This is like what I told. It's as I said, search engine for internet of everything. You can actually like if you want like I know it may be like a bit of problem. There may be webcams that are connected all over the internet, or say like CCTVs that are connected to the internet, and the people may have left it open, like due to their lack of knowledge. These may be left open, and we can actually like we may be able to access it. One of the times I was able to access one of the CCTV cams in like Mexico. So imagine the kind of threat that is possessing. So as you can see, like this is actually a CCTV that is in UK, and it actually gives me all the information about that CCTV. What all are the security threats that this is possessing, and a lot of stuff like that. So it is basically used by cybersecurity experts to analyze the security of the IoT systems. As you can see, this is actually a device from Russia, and you can see the open ports over here. This much ports are open, and if you are a real hacker, you can actually hack the system and get into one of these ports and access it from your location. So that is one of the major problems of IoT. The security is one of the major issues that we are currently facing, and I hope that we may be able to solve it. But like we know that as long as the humans are involved and the like human knowledge is involved, a small bit of security issue will always be there. That is always redundant. So that's much about the security aspect of IoT. So that's much it about the session on IoT. I hope you got a brief idea about IoT, and also how to get into IoT, some of the development boards, some of the sensors, So my intention was to like provide like stepping stone to IoT for those who are interested. So I believe that I've covered much of them. And if you have any questions, please feel free to ask them now.
Thank you so much, Amit. That was a very informative session. Now we have a few questions in the live chat. So I'll read it out. The first
Sure.
question is, how to land in a good job in IoT? Companies, things to learn, and other opportunities in the field.
Okay, so actually one of the major like problems is that in most of our college there won't be any recruiter coming and saying we need an IoT developer. So it's one of the like what you say dedicated fields. You first need to get into embedded systems. There are a lot of embedded related companies like Bosch, also TCS Digital. Such companies are there. You need to get in to that kind of companies that offers embedded developer roles, and further you can get into the IoT segment. There is no, in my knowledge, there is no like recruiters that comes on campus to recruit IoT developers. So, or else you may have to try for off-campus interviews. There are a lot of opportunities that are available at famous companies like Bosch, Siemens, Schneider. A lot of companies offer IoT solutions, and nowadays there are a lot of Kerala-based startups as well that are like working on IoT-related technologies like LoRa, like Sigfox, etc. So I think that if you are looking forward to IoT, first like working in a startup environment would be much beneficial, because it's a bit hard, or it's not a niche kind of job role. Like we say like web developer or software developers, etc., are very much common these days, but IoT developers are like comparatively less hard to find, or are less available. The job posts are less available, or that is currently booming only. So you might want to consider getting into an embedded kind of role first, then then switch into IoT, or you may consider getting into a startup like environment to further know about it. I hope I've answered the question.
Okay, so the next question is, suggest a good microcontroller to get started with IoT.
Can you repeat the question? Like which is a good? I didn't get that.
Suggest a good
Okay.
microcontroller.
Okay, got that. So the best microcontroller that I would suggest would definitely be ESP8266. It is also known as Node MCU. It costs only under 300 rupees. Why? The reasons for suggesting that would be like it has Wi-Fi chip inbuilt in it. You don't need anything else to connect to the internet. It has an inbuilt Wi-Fi chip. But in the case of like when you talk about this development boards or microcontrollers, first name you would hear is Arduino Uno, or Arduino Mega. But all those microcontrollers cost like, or even the duplicate ones cost around like 700, 800 rupees, and they do not have a Wi-Fi chip. So you cannot have an IoT application running on them. So in order to have this IoT application running, you can get this ESP boards under like 300 rupees. It automatically has a Wi-Fi chip. So and get a bunch of sensors, like as I showed you before, get a bunch of cheap sensors and try it out your own. So the answer would be like ESP8266 Node MCU, or if you want to get a more advanced version, go for ESP32. So that would be it.
Okay, so the next question is, what do you think are the major challenges IoT industry is facing in home automation?
So the major challenges, to talk about the major challenges, would definitely be security. Security has always been the number one threat of IoT related applications, because like an year or before, we know that most of the like homes in US has either a Google Home Mini or an Amazon Alexa. So there was a case that was filed because this Amazon Alexa and Google Home Mini actually collects our voice clippings, or it can involve like personal information, right? So it is actually an invasion of privacy as well. So there are a lot of cases that are currently in the court related to privacy. So that is a big issue. Second issue would be, as I said, security. Like if people with no prior knowledge or less knowledge like develops these IoT related systems, it can lead to a lot of problems. We also know that this the Tesla car is a great example, like for a car that's running on IoT technology. It's fully automated, right? So imagine that like it has self-driving technology, and one day it goes out of your control. So that controllability issue and that security issue would mainly be the two challenges that the IoT industry is currently facing, and it is really hard to like rectify that to a 100% extent. The like even if we are able to solve these problems, another problems would rise. But that is the interesting part of IoT. Not only IoT, any technology, we always have problems. It's about solving those problems. There won't be any situation in which we have a 100% perfect system. There is no system as such which is not hackable or which is 100% secure. So the security as well as controllability is two of the major challenges.
So the next question is, what are your thoughts on Apple entering home automation with IoT?
Apple entering home automation, like it's already there, but still, it's actually a like already. What I feel is that even Google as well as Amazon are already top contenders in the market. So currently, Apple has been stepping in, but even like I believe that even in our country, like consider the case of India, like most of the home automation systems that we use will be Google Home Mini or Amazon Alexa. Like Apple entering this IoT field would definitely be, they will enter, that's for sure. But if they're entering, like they should bring something different, because Amazon entered, Google entered, there are a lot of allegations against them, as I said before, regarding this privacy issues and all. If they can tackle that, and like if they can provide this, Apple has always been known for the security factor. So if they can add another layer of security or ensure this like privacy related like tackle this privacy related problem, I think that they'll be a great contender for this IoT market.
I guess that was the last. Now we'll conclude the session. Knowledge is power. Knowledge shared is power multiplied. Thank you, Amit, for this amazing session. It was truly enlightening. I would like to extend my gratitude to the audience and hope you all enjoyed the talk. Until next time, good night.